Io, the hellish moon of Jupiter. Our planet's volcanoes are a distinctive characteristic. In comparison to the other solid planets in our solar system, our Earth is a young planet. Some worlds have sporadic volcanic activity, while others have none at all. However, there is a peculiar region in our solar system that has more volcanic activity than any other. In 1610, using a telescope, Galileo found 4 enormous moons around Jupiter, our largest planet. The planet Io was the closest, then Ganymede, Europa, and Callisto, which was the planet that was the furthest away. When we look at Io closely, it seems to be very different from the other worlds, whereas Callisto and Ganymede are large and heavily cratered and Europa appears to be covered in ice. What makes Io unique in our solar system and what makes it so special? In this video, we're about to learn the answer. The Earth's crust is the thinnest of its layers, but it is neither uniform nor unique. Where the deeper mantle is packed heaviest beneath the surface of the Earth, the crust is the thinnest and easiest to penetrate. In contrast, the crust gathers the most if the mantle does not start until it reaches its greatest subterranean depths. Many processes and interactions, such as plate tectonics, cause the rocks beneath the Earth's surface to melt at the crust/mantle boundary. This causes magma chambers to form. Our planet has a low surface-to-mass ratio, which makes it difficult for that energy to escape, accumulate, and then release irregularly during catastrophic events like earthquakes and volcanoes. The Earth's crust is the thinnest of its layers, but it is neither uniform nor unique. Where the deeper mantle is packed heaviest beneath the surface of the Earth, the crust is the thinnest and easiest to penetrate. Since ice is less dense when solid than when liquid, you are certainly familiar with ice melting and have probably seen that ice floats over water. In this sense, water is a relatively uncommon element, being responsible for everything from icebergs in the ocean to ice cubes in your summertime beverages. Most materials, including rocks, have a less dense liquid phase than a dense solid phase. And because of its decreased density and buoyancy, magma that is formed below the surface tries to rise as it expands, shattering and displacing the solid rocks on each side. Volcanic eruptions happen frequently each year at various sites all over the Earth's surface when enough magma creates enough pressure. On most stony planets, this is not the case, though. The crust of the Earth is very young compared to other solid worlds. Contrast the surface of the Earth with that of Mercury or the Moon, where craters have been present for billions of years and have not been impacted by volcanic activity. Since the formation of the solar system, these small, geologically inert, at least relatively inactive, worlds haven't had a good resurfacing, in contrast to the Earth, which is teeming with volcanic eruptions, magma vents, and regular eruptions. There are volcanoes on worlds you might not expect, like the tiny moon Io of Jupiter. Io seems to be an unlikely candidate for volcanoes given that it only makes up 1.5% of Earth's mass but accounts for more than 25% of its circumference, and that it has had more than enough time, 4.5 billion years, to cool and become stable. Io is far from steady, though. Before we even had a close look at it, a number of volcanic outbursts were predicted. During its voyage to Io, the Voyager 1 spacecraft found hundreds of volcanic calderas, as well as actual eruptions with plumes 300 kilometers high. Then, it was discovered through studies from Voyager 2, Galileo, and several telescopes that these eruptions change rapidly on Io's surface. When we look at Io closely, it seems to be very different from the other worlds, whereas Callisto and Ganymede are large and heavily cratered and Europa appears to be covered in ice. It has a face covered with pockmarks and is covered in stones, resembling a teenager who won't stop scratching. Io does, however, have one characteristic that sets it apart from the other stony worlds we've found: there are no craters. There's a good reason for this, as we've learned. And if you thought the tides on Earth were horrible, wait until you saw those on Io. However, are you aware of Io's 2 shining regions? Those volcanoes are exploding right now since they are active ones. You may assume this is a once-in-a-lifetime event that we just happened to witness if you're used to witnessing volcanoes on Earth. Since there are two eruptions occurring simultaneously, they must be quite spectacular if they can illuminate the entire surface of the planet in this way. But a closer look, or rather, repeated inspections of Io, show that these outbursts are exceedingly frequent. The solar system's most recent surface is that of Io. Why does its surface not appear to have any craters? These eruptions, which occur over periods of thousands to tens of thousands of years, cover the entire planet with a fresh layer of lava that eventually turns into rock. What is the root of this? The simple answer is Jupiter, which acts as a cosmic Zamboni on Io, resurfacing and spewing lava on the surface as if it had nothing better to do in the universe. The combined tidal forces of Jupiter and the outer Jovian moons are responsible for all of this energy. Ocean tides rise and fall by an average of 1 to 2 meters on Earth due to the gravity of the Sun and Moon, which is far too low to induce any appreciable heating. Io doesn't have any oceans, yet the tidal pressures it is subject to cause the Earth to swell and contract by an amazing 100 meters at a time. In the same way that quickly bending a piece of metal back and forth causes it to internally heat up, this not only creates breaking and fissures, but also heats up the planet. That interior heat escapes through dormant lava flows and destructive volcanic eruptions when a route to the surface becomes available. Io has the most extreme temperature variations of any object beyond the Sun, with certain areas of its surface reaching 1,200 degrees Celsius (2,000 degrees Fahrenheit), compared to an average surface temperature of 110 Kelvin (-163 degrees Celsius, (-261 degrees Fahrenheit). Minor tides are produced by the combined effects of the Moon and Sun on Earth. These tides cause the oceans to rise and fall by 1 meter at a time and the crust to expand and contract by a few millimeters or centimeters with each rotation. However, compared to what we feel on Earth, Jupiter's tidal forces are 10,000 times more powerful on the moon Io. And because of this, practically every circle the moon does around its steward planet tears the surface of Io away. Jupiter's tides produce magma just beneath Io's surface, then rip that surface apart, allowing it to climb to the crust in a permanent state of eruption, unlike our tides, which cause the oceans to rise and fall. The tidal forces on Earth would have the same impact as Io's, making it nearly uninhabitable if our moon were 20 times closer to the planet than it is presently. Fortunately, the moon is safely out of harm's way, and any resurfacing is brought on by Earth's natural physics rather than by the tidal pull of a